Students, today we will start with exercise 8.2 of chapter number 8, quadrilateral. For starting with the exercise, first of all you have to remember midpoint theorem. So what is midpoint theorem? Suppose if you are having a triangle, suppose triangle A, B and C. This BC is the base of a triangle, that is your third side. Suppose if two midpoints are there, suppose if E and F. This E and F midpoints, they will be parallel to your third side. Means EF will be half of BC and also EF will be parallel to BC. Okay, EF is half of BC also, and EF will be parallel to BC also. So this is your midpoint theorem. Now if you want to prove converse of midpoint theorem, then what you will prove? You will prove that F is the midpoint of line segment AC. Okay, this way you have to go with the proof. Now first question number 1 of exercise 8.2, that is ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the side AB, BC, CD and AD. Okay, and AC is a diagonal. You have to show that SR is parallel to AC, SR is equals to half of AC, PQ is equals to SR and PQRS is a parallelogram. You have to show these things. So first of all, first question. For proving first question, what you will do, you will, in the given figure, you will take a triangle, that is triangle ADC. If you will take triangle ADC, then S is the midpoint of AD and R is the midpoint of CD. When you will draw your triangle in a straight manner, so you will have AC over here and D point you will have at the top. Here you are having D and here you will have midpoints, that is for AD you are having S and for CD you are having R. So this is the midpoint. Now same condition like midpoint theorem. So your first condition will be SR parallel to AC and SR is equals to half of AC. This is your first condition. Now take another triangle, that is next triangle below the diagonal, that is triangle ABC. If you are considering triangle ABC, then again the same reason, that is PQ will be parallel because here P is the midpoint of AB and Q is the midpoint of CB. So PQ will be parallel to AC over here. So again you can write PQ is parallel to AC and PQ is equals to half of AC. Now from this two result, we came up with the conclusion that PQ is parallel to SR because there SR is parallel to AC and PQ is parallel to AC. Both these line segments are parallel to one line segment only, that is the diagonal AC. So you can directly write SR is parallel to PQ. Okay, and next condition you can write if SR is equals to half of AC and PQ again is equals to half of AC. So you can write SR is equals to PQ directly. So this is the third condition. Now second condition you have to prove PQ is equals to SR. Now if PQ is equals to SR, so you can directly write from 1 and 2. Then third condition, PQRS is a parallelogram. So if one side of a parallelogram is parallel and equal, then you can say that the given quadrilateral is a parallelogram. So here you are having PQ is parallel to SR and PQ is equals to SR. So clearly one pair of opposite side of a quadrilateral PQRS is parallel and equal. So hence PQRS is a parallelogram. Then come to question number 2. Question number 2 is ABCD is a rhombus and PQ, R and S are the midpoints of the side AB, BC, CD and AD respectively. Show that the quadrilateral PQRS is a rectangle. First of all, you are given that the given figure is a figure of a rhombus. So rhombus you are given. So in what is the property of a rhombus? That all sides are equal, diagonal bisect each other at 90 degree and opposite sides are parallel. Okay, so this is the property of a rhombus. Now you have to prove that the given quadrilateral is a rectangle. So again to start with the proof, you are given two diagonals. So we will take a diagonal and we will take two triangles. So first of all we are taking triangle ABC. If you are taking triangle ABC, then in triangle ABC, if you are making the triangle straight, so B will come over here and AB, P is the midpoint and BC, Q is the midpoint. So this is your condition. So according to this condition, you will get your first result, that is PQ is parallel to AC and PQ is equals to half of AC. This is your first condition. Then after your second condition, that is for triangle, next triangle, that is for triangle ADC. If you are taking ADC, then S and R are the midpoints. So there you will have here point D, and for AD you are having S, and for CD you are having R. So again you will have this type of condition. Now from result number 1 and 2 you will have PQ parallel to RS and PQ is equals to RS. Now if PQ is parallel to RS and equal to RS, then you can write that the given quadrilateral is a parallelogram. Now if the quadrilateral is a parallelogram, if it is satisfying the property of a parallelogram, then after if you have to prove rectangle, so you have to prove any one angle of a parallelogram as 90 degree. So this I am giving you in homework, that is same as exercise 8.1 question number 2. Okay, same as the first exercise, that is exercise 8.1 question number 2. You have to prove any one angle 90 degree. So half of the sum is done, and half of the sum you will prove in your homework. Then after, come to question number 3. Question number 3 is ABCD is a rectangle and PQ, R and S are the midpoints of the side AB, BC, CD and AD respectively. Show that the given quadrilateral PQRS is a rhombus. You have to show that the given quadrilateral is a rhombus. Okay, so for proving rhombus you have to prove all sides equal, and you know in a rectangle you are having diagonals equal, and then after you are having opposite sides are equal and parallel, then after you are having all angles are 90 degree. These are the properties of a rectangle. So first of all you have to join the diagonals. So let us join AC and BD. Now in triangle ABC, now see for triangle ABC, if you are considering, again you are having the midpoint theorem, that is P and Q are the midpoints. So by using midpoint theorem you will have PQ is parallel to AC and PQ is equals to half of AC. This is your result number 1. Then again next triangle, that is triangle ADC, again midpoint theorem. So your SR will be parallel to AC and SR will be equals to half of AC, again by using midpoint theorem. So from result number 1 and result number 2 you will have PQ is parallel to AC and SR is parallel to AC. So PQ will be directly parallel to SR and PQ is equals to SR. So if in a quadrilateral PQRS one pair of opposite side is equal and parallel to each other, then the given figure is a figure of a parallelogram. Okay, so the given figure is a figure of a parallelogram. So in the same way you can prove opposite sides are also equal and parallel. So you can directly write PS is equals to QR, because opposite side of parallelogram, and if they are equal they are parallel also, PS is parallel to QR. So this is equation number 3. Now take another triangle, that is triangle BCD. Now in triangle BCD, again you are having same thing, that is Q and R are the midpoints of BC and CD respectively. So QR will be parallel to BD and QR is equals to half of BD. So this will be your equation number 4. Okay, now however the diagonal of a rectangle are equal. This is the property of a rectangle. Okay, the diagonals are equal. So if the diagonals are equal, you can write AC is equals to BD. That is equation number 5. Now if you are solving all these equations, okay, so you will get all the sides are equal. That is, if you are solving, so you will get in this way, that from result number 1, 2, 3, 4 and 5 we obtain that PQ is equals to QR, that is equals to SR and that is equals to PS. Now if all the sides you are getting equal, that means you are having two properties, that either rhombus or square, but in your figure it is given rhombus, so we will write rhombus. Okay, so therefore PQRS is a rhombus. Then after question number 4, ABCD is a trapezium in which AB is parallel to CD and BD is a diagonal and E is the midpoint of AD. A line is drawn to the midpoint parallel to AB intersecting BC at F. Show that F is the midpoint of BC. Now you have to show this F is the midpoint of BC. Okay, so this is the figure. Now EF and BD, they are intersecting at a point and that point is point G. So now by converse of midpoint theorem, you know that a line drawn to the midpoint of any side of a triangle is parallel to the third side, bisects the third side. Okay, so in triangle ABD, if you are considering triangle ABD, see for triangle ABD if you are considering, then you are having EF parallel to AB and E is the midpoint of AD. Therefore G will be the midpoint of BD. Okay, if you are considering this triangle, so E will be the midpoint of AD, so therefore G will be the midpoint of BD. Okay, now as EF is parallel to AB, AB is parallel to CD, so can we directly write EF is parallel to CD? Yes, because two lines parallel to the same line are parallel to each other. This is the reason. Now in triangle BCD, now if you are considering triangle BCD, other triangle BCD, if you are considering this triangle, so here G is the midpoint of BC, that is you had proved. So if you are writing GF is parallel to CD, Okay, if you are writing the side is parallel, then you have to write that f divides line segment BC into two equal line segments, that is f bisects line BC. So if it is bisecting, so we can write f is the midpoint of BC. So in triangle BCD, GF is parallel to CD and G is the midpoint of line BD. Therefore, by converse of midpoint theorem, F is the midpoint of BC. So you can write this by converse of midpoint theorem. Now question number 5, question number 6 and question number 7 all are based on the application of midpoint theorem only. So you have to do. Now in question number 7, last, that is CM is equals to AM, you have to prove. In that, first of all you will prove two triangles congruent, and then after you will have to use CPCT condition. Then after you can prove that it is equals to half of AB. Okay, so question number 5, 6 and 7 are there in your homework. All are based on midpoint theorem only. You don't have to use any other theorem, any other criteria. You don't have to use directly application of theorem number 8.9, midpoint theorem. Okay, so you have to solve these three questions in your homework. So we are done with the chapter, that is chapter number 8, exercise 8.2 we had completed.